Hello and welcome to my science tutorials. In today's video, we want to look at binomial theorem, where we'll be solving some objective questions on binomial theorem. Now, let's have a little recap of what binomial theorem is. So when we talk about binomial, the term binomial, is an expression that consists of two terms connected by a positive or a negative sign. So a binomial consists of two terms that is connected by either a positive or a negative sign. That is what we call a binomial. So for example, if I have x plus a, this is a binomial because it has two terms and it's connected by a positive over here. If we have, let's say, 2x minus 3y squared, this is also a binomial because it has two terms and it is connected by a sign over here, which in this case is a negative sign. Now let's say we have a binomial expression and we have to expand it. How do we do that? Now there are two ways. We have one, what we call the Pascal's triangle, which we'll be treating in another video. And then we have the normal binomial way of doing it. So the binomial method, let me put it that way. We can use the Pascal's triangle, or we can use the binomial or the expansion method. So for the second method, which is what I will be using, so for instance, let's say we have the expression a plus x all raised to the power n, and we are to expand this particular expression. How do we do this? Now, to expand this, the first thing we do is that we take the first term over here and we raise it to the power over here. That's the first thing we do. So we have a raised to the power n. Now, we write plus. Then the next thing we do is that the exponent over here, the n, becomes the first term for the next term or the second term in the expansion. So the n here will become the first term. You have n. Then you multiply it with the first term, which is a. Then you multiply it with a. Now the power that it has over here is n. But in this case, you reduce the power by 1. Are we okay? Then you introduce the x. So x will come over here. Then plus. The next thing you do is that the n over here, you subtract 1 from it and add it to the n. And multiply it with the n over here. So you have n, which is the first one over here. Then you subtract 1 from the n. Then you multiply it with the first term, which is a raised to the power n minus. This time around, you not subtract 1, you subtract 2. Are we okay? We can see how this is going, which means the power of the a term is decreasing as you expand more. But then this time around, we'll include the x, but we'll square it. We'll square it over here because over here we don't have the x because the x here is power 0. So it is any number with the power 0 is 1. So we don't write it over here. The second one over here, the x is raised to the power 1. Are you okay? So you can either write it or leave it. Over here, it will be raised to the power 2. Now, the second one over here, this one will be over what we call 2 factorial. Now, I'll be explaining what factorial means. It means that here is over 1 factorial. And here you can say it's 0 factorial. Are you okay? So this is over 1 factorial, this is over 2 factorial, but normally we don't write over the 1 factorial, we don't write it. So plus, the next thing we'll do is that we'll subtract minus 2 from the n. So we'll repeat the n, then the n minus 1, then we add the n minus 2 over here as the next term. So you can see that the n is also decreasing by 1 as you go. Then the a over here will also decrease by 3 now. So it will be a raised to the power n minus 3. Then the x will have the power of 3 now, all divided by what? 3 factorial. Okay, this is how we expand. So you expand it until you have x raised to the power n, which will be the last term for your expansion. So this is how we expand binomial questions or expansions. This is how we do the binomial expansion. Now, I suppose you know this by now, but just so that in case you don't know, this is how we do the expansion. So send a video back and look at how I did the expansion and practice it yourself. Now, by factorial, what we mean by factorial is 2 factorial is 2 multiplied by 1. 3 factorial is 3 multiplied by 2 multiplied by 1. It means that the factorial means the number, the highest number, multiplied by the number before that, multiplied by the one before that. Okay, but the least is going to be 1. So if I have 4 factorial, this will be 4 multiplied by 3 multiplied by 2 multiplied by 1. Now if I have 7 factorial, this will give me 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. This is 7 factorial. Okay, so this is how we expand a binomial expression. So let's take that again. So we are saying that, let me use a different color just so that we can grasp the understanding. So we are saying that if we have the expression a plus x all raised to the power n, to expand this, the first thing we do is that we take the first term over here, which is a, and we raise it to the power n. So we write a raised to the power n, then plus. The next thing we do is that we bring the power forward, which the n will now come here, multiplied by the a raised to the power n, but minus 1. The power of the a will reduce the more you expand. So we have a here is the power n minus 1. And then we introduce the x, which is the second term over here. Okay, multiplied by x. Then plus the n over here. Now we'll subtract 1 from it. So we have n into bracket n minus 1. Then multiplied by the a now will reduce by power 2. So a n raised to the power 2. Then the x now over here is power 1, but here it will become power 2. Okay, the more you go, the exponent of the a is decreasing, but that of the x or the second term is increasing. Okay, so we have that over 2 factorial, then plus, then you have your n minus 1 from this one, then you introduce n minus 2. Okay, then you have your n now will now decrease by 3, your x will now increase by 3, and then you have over 3 factorial. Okay, then it continues like that. So in this expansion, we call this one over here is what we call our first term. Are you okay? This is our second term. Okay, this is our third term. Okay, and this is our fourth term. Are we okay? So that is how we solve or how we expand binomials. Now, this whole expansion I'm doing, okay, how do we apply this? So, for instance, let's try this past objective question. So we have we have to find the coefficient, find the coefficient, find the coefficient of x raised to the power 4 in the binomial expansion, in the binomial expansion, the binomial expansion of 3 minus 2x raised to the power 6. Are we okay? So we have to find the coefficient of x raised to the power 4. Okay, now if you look at it, we've only expanded up to x raised to the power 3. Are you okay? So if we continue from this expansion, the one at the top over here, the fifth expansion after here, which will have the coefficient of x raised to the power 4, will be from here. Okay, I'm using from here. Let me use a different color so that we can all follow along. Okay, so from here, okay, from this expansion, the next one will be n minus 1, n minus 2, n minus 3, n minus 4, because this is minus 3, so here it will be minus 4. Then we have x raised to the power 4 all over what? 4 factorial, because this was 3 factorial. Okay, so this will be the next expansion after this particular one. And for this particular question, that is what the question is saying. The question is saying we should find the coefficient of the x raised to the power 4 term. Okay, so we have the x raised to the power 4 term over here. So it means that, okay, so let's keep this expansion in mind. This is what we'll be using to solve this particular problem. Are we okay? So let me quickly erase that so that we have space to attempt the question. Okay, so I believe you've copied it. If you've not, I think you can just move the video back and then you see that. Okay, so in this particular example, remember that when we are using the term a plus x raised to the power n, then the coefficient of the 4x raised to the power 4 term, or the expansion, will be n into bracket n minus 1, n minus 2, n minus 3, a raised to the power n minus 4, x power 4, all over 4 factorial. That is if we are using this. But the question is giving us the expansion 3 minus 2x raised to the power 6. Okay, this means that if I compare this to this, okay, the a over here is the 3 over here, so the a is 3. Now the x over here, the x at the top over here, is the negative 2x over here, so the x is negative 2x. And then my n is equal to what? The 6 at the top over. The power over here is the 6 over here. Okay, so now all I have to do is that I have to do this substitution in here to get my answer. So if I substitute this into the top, this is what I am going to get. I am going to get the first n, which is 6, multiplied by n minus 1, which is 6 minus 1, that will give me 5, multiplied by n minus 2, which is 6 minus 2, that will give me 4, multiplied by n minus 3, which is 6 minus 3, that will give me 3. Okay, then into bracket, my a in this case is 3. Are we okay? The a over here in this case is 3. Remember, we are doing substitution, so I have 3 here raised to the power 6 minus 4 because the n is 6. Okay, then I have over here the x over here. Mind you, the x is not just x, the x is minus 2x. The x over here is minus 2x, what we have over here. Okay, remember, this a plus x is the expansion we have over here. So for this particular one, the x is minus 2x. So we have here minus 2x raised to the power 4. Okay, sorry, the thing has gone into the corner, but you get it, all over 4 factorial over here. So the 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. Are we okay? So let me do the demarcation wall. So okay, so from here all we have to do is to solve this problem. So the 4 here will cancel this, the 3 will cancel this, the 2 go here once, to go here 3 times. Are we okay? Then we only have 1 at the denominator. So over here I have 3 multiplied by this will give me 15. So 15, then I have into brackets 3 raised to the power 2 over here. Okay, because 6 minus 4 is 2. Then I have over here negative 2 raised to the power 4. Okay, now negative 2 raised to the power 4 is positive 16. So I have positive 16. Then x raised to the power 4 is x power 4. Okay, all over 1 is still the same thing. So I have over here, I have 15 multiplied by 9 multiplied by 16 x power 4. Okay, all divided by 1, which will give us the same thing. So if we quickly compute this into our calculator, what do we get as the coefficient? So just a minute, let me get my calculator. So I have 15 multiplied by 9 multiplied by 16. That will give me 2160. So my answer over here, my answer for this particular question, okay, will be 2160 x raised to the power 4. Are you okay? So this is the expansion, and then the question is saying we should find the coefficient. So our answer over here, the coefficient here is 2160. Okay, this is the answer that we are looking for. Okay, now if you are new to this whole binomial expansion thing, this whole example will be a little bit confusing. So let's look at another example so that you can really appreciate what we are talking about as binomial theorem. So the second question is we are to find the coefficient in this question, all we are doing is finding a coefficient. We are not expanding anything. So we have to find the coefficient of y cube in the binomial expansion of x minus 2y raised to the power 4. Are we okay? So we write down our solution. Now the question is saying we have to find the coefficient of y cube in the binomial expansion this, right? So the first thing we do is to quote the normal way of expanding the binomial, which is the a plus x raised to the power n. Are you okay? So the first thing we do is we write the first term raised to the power n. So we have a power n, then plus the n will now come first, n. Then we have a raised to the power n. We subtract 1. Then we introduce x, plus we have the n, then the n minus 1. Then the a n, the power will now be subtracted by 2. Then we square the x, but then we divide by 2 factorial. Then plus we have the n into bracket n minus 1, n minus 2. Then we have a n minus 3 s cube all over 3 factorial, and then we continue that way. Okay, now in this case we have to find y cube, so it means y cube, and then the y is the second term over here. Okay, so it means that the second, once we have x raised to the power cube, it's okay for us. Okay, now let me use a different color so that we can appreciate. So we have the question is actually x minus 2y raised to the power 4. So in this case, our a is x, our x is negative 2y, and then our n is 4. Let me write that here. Our a is x, our x over here is minus 2y, our x is minus 2y, and then our n is power 4, or 4. Are you okay? If that is the case, and then we have to find the term, the coefficient of y raised to the power 3, it means we'll find it over here. We'll find it over here. Because mind you, the x raised to the power 3 over here is minus 2y raised to the power 3. So we'll get y power 3 over here. Are you okay? So we are using this. So our answer for this particular one, x minus 2y raised to the power 4, will be equal to n minus 1, n minus 2, a n minus 3, s cube all over 3 factorial. And this will be equal to, our n is 4. The 4 minus 1 will give us 3. The 4 minus 2 will give us 2. Then our a, in this case, is x. So we have x raised to the power, the n over here is 4. So 4 minus 3. Then our x over here is negative 2y. So the x is a negative 2y. Remember, the x is cubed, so I'll write the cube over here, all over 3 multiplied by 2 multiplied by 1. Are we okay? So from here, we just compute all we have over here. So 4 multiplied by 3, that will give us 12 multiplied by 2. Okay, let me cancel. So this will cancel this. This will also cancel this. Okay, so we are done with the denominator. So I only have 4x. This one will have x power 1. So we write x power 1, or we just write x. Then minus 2 cube will give me minus 8. So it will give me minus 8. Now y cube will give me y cube. Okay, so this all over 1. All over 1 over here. So this is equal to 4 multiplied by negative 8 will give me negative 32 x y cube divided by 1, which is still negative 32 x y cube. So our answer over here, the question is saying we should find the coefficient of y cube. Over here, the coefficient of y cube over here is the negative 32x that we can see over here. This part. Okay, this is the answer. Negative 32x is our coefficient of y cube, as we can see in the question over here. So basically, this is how we find the coefficient of a binomial expansion. I will do another video where we'll look at the binomial expansion itself. Then we'll look at the Pascal's triangle, how to use the Pascal's triangle, how to solve problems on the binomial theorem itself, and many more. So I will give one example so that you can solve and then leave your answer in the comment section below if you've watched up to this point. So try your hands on this question as homework and then leave your answer in the comment section. So we have to find the coefficient. Sorry. Find the coefficient. Yes, find the coefficient. Sorry. Let me erase that. So this is a little bit different from the previous one. So if the coefficient of x cube in the expansion of k plus 3x raised to the power 4 is 54, we have to find k. This is the question. So they are saying that if the coefficient of s cube term in the expansion is 54, we have to find the value of k. Mind you, when you are expanding to get to the s raised to the power cube term, you will have to do that and get the one that has 3 factorial and that. So for instance, if I'm using my normal a plus x raised to the power n, I will have a power n plus n a power n minus 1 plus n minus 1 a n minus 2 x. Sorry, this one you introduce the x over here. This will be s squared all over 2 factorial. And then you have here n minus 1, n minus 2, then a n minus 3 s cube all over 3 factorial. Are you okay? So in this particular case, or in this particular problem, this guy, okay, is what you are going to equate to 54. Are you okay? So this particular guy should be equal to 54x cube, because they say the coefficient of the s cube is 54. So it means if you expand everything over here, the answer you're supposed to get should be equal to 54s cube. So whatever you get after substituting the values over here into this expression will be equal to 54s cube, and then you can now divide by 54 to get, sorry, you can now divide by whatever you get over here. You divide over here and then you get the value of the k. Are you okay? So try your hands on that and leave your answer in the comment section and I will be sure to reply. So thank you so much for watching, and I will see you in the next video. Bye bye.